So we're not going to let that happen to you. So I'm going to go ahead and get talking. First thing I want to talk about is your quizzes. This class actually doesn't look bad. I've glanced through them. I haven't graded them all. I'm determined to have them all graded tomorrow. In fact, I'm going to put my money where my mouth is. I don't have your quizzes graded by tomorrow. Then to me, that means you don't have time to review it. So how can we take the test on Tuesday? The test we push back to Wednesday. So I'm going to have them graded by tomorrow. I'm not moving that test. That's Tuesday. So why do we need the piecewise quizzes graded? Because piecewise functions are going to be on our next test. They are. It is what it is. So there are 3 sections on our next test. We did piecewise and we cried a little bit. We did. It's okay. That was the hardest. We did graphing linear inequalities yesterday. That was the easiest. But today is not going to be a hard day as long as you're paying attention as well. In fact, let me go ahead and stop my rambling and say, if you do not have, I know some people already have one because people left them out because they can't follow directions. But if you do not have a graphing calculator, today would be a great day to come get one because we're going to learn how to use it and learn some really cool buttons on it. It's going to save our souls. Well, not really, but it is going to help us out a lot in my class. I got like 5 homework going on. It's driving me wild. Why? Why are you telling me? Really about to grade. It's fine. I knew it was going to happen. I just didn't know it was going to be you. That's why we don't walk around with a backpack. Would be my joke, but you know, you do. Xavier, you do me a favor and go get me some water. Thank you. Leave them. They're fine. It's bound to happen.
Yes. No, not math.
Okay, so you got your graphing calculator. You're going to learn how to use it today. I had someone last period who was too sweet to tell me the entire class period they had a Casio. If you have a Casio, like you have your own personal calculator, and it is a Casio. It's a brand. We're not learning how to use those today. You want to get, and she did exactly what I wanted her to do. She got one of my TIs. It's like trying to explain. You can't explain to someone who's holding an iPhone and you have a Samsung in your hand how to do things. Same way with a TI and a Casio. At the top of it says TI, you're good.
TI 84.
Then you're good. But if it says Casio at the top, it's probably a different one. So I'm not explaining how to use Casio today. Only with TI. In fact, to be honest with you, like an iPhone and Samsung user, I'm an exclusive TI person. So if you ask me how to do Casio stuff, I might can figure it out, but honestly, I would just Google it, and there's probably a YouTube video for it. That would be the easiest way to handle it. And I would suggest buying a different calculator, but that's just my 2 cents, because I'm a TI person. Can't help how I am. Okay, so we've done 2 sections. This is our last section. It's going to take us 2 days. Today we're going to do just graphing. Tomorrow we're going to do just describing. And then you have some pages for homework. Remember how last Monday went when you kind of forgot you had homework and didn't turn it in? Yeah. We don't want that repeat. So I'm going to give you some time during class today. I'm going to give you time during class tomorrow. Surely to goodness, Andrew can just have it done before he leaves the room tomorrow. That way he can go ahead and show it to me and not have to do it this weekend. I'm hoping instead this weekend, maybe if he messed up on that piecewise quiz, he'll study over that and get his lapwise right with piecewise functions. Okay, so all the calculator things. In fact, let's go over how to do something basic in the calculator first before we even go over the math workshops, bless you. Let's talk about how to clear it out. Because if you're using one of mine, a lot of people have used it. So, and in fact, a lot of stats kids use my calculators, and they done mess everything up for you. So let's talk about how to clear it out. If you don't want all this, what is this? So you could press the second button, and then MEM, it's written in blue near the plus sign. And then I see a button that says reset. It's 7. So I hit 7. And then just like your phone does, it asks, or like your computer does, it asks you like, are you sure you want to do this? You want to clear all the RAM? And you're like, yes. And then it asks you one more time, are you sure you want to reset? Yes, I want to reset. And then it clears it out entirely, which is a suggestion I have if you're using a shared one. But if this is yours, you know, eventually Caitlin likes that it's always set in degrees or radians. Like she has things set a certain way. So she might not want to do that. That's just my suggestion if you're using a communal one and it's driving you wild. Okay, if you're too polite to do that, because you realize when you do that, you're clearing out everything they stored in it. It's gone. I mean, they're bad for having done that. But anyway, so if you're not wanting to do that because you're too polite, if it looks like some stats junk, meaning you press the graph button and it looks like an alien or something happened, like you just don't know, you need to turn off the stat stuff. So you'll press second stat plot, and then you just need to make sure that all the words say off. Because otherwise there's some stat junk turned on and you need to turn it off. If you're not using one of mine, that's never going to be on for you. If you're using one of mine, I teach AP Stats. They use my calculators a lot. It's probably on. You need to turn it off. Yeah. Statistics. Okay. So, if you want out of anything, because you're like, where am I? I don't need to be here. If you press second quit, it gets you out. Or just like your phone, if you turn it second off and just power it off and turn it back on, it starts over again. So, it doesn't clear stuff out, but it does get you out of whatever screen you were stuck on. So, second quit, or second, and then off. It's the on button, but it's written in blue, so second off.
I could have sworn I've used the second option before, but it's not. It didn't take me out of the page.
Then I would do second quit. Sometimes it doesn't if you're in a graph page. So I would do second quit then. Okay, so we're going to come back to graphing with it in just a second. But that's how you can clear it out and make sure no one else's junk is in your way. Okay. As for these math workshops, so I have a volunteer for number 7. Yes, Travis. 16 squared of what? 3? You can have a point. So you were supposed to do another point's available. What's 16 squared? 16 squared. You memorize perfect squares. Thank you, Abby Grace. You get your point. 256 times 3 is 768. Good grief. 256 times 3 was 768. It was a big perfect square. Hey, I know the square root of 256 is 16. Those perfect squares are supposed to come in handy. There's a reason we learned them. Did I say get a point, Abby Grace? If I didn't, I should have. Get a point for that. Okay, so square root of 576, number 2. Yes, rating.
24.
It is 24, and you get a point for that. That was one we were just supposed to know. It was a perfect square. Okay, number 9. Any new volunteers before I let Travis handle it?
Go, Travis.
Okay, go ahead, Travis. Say it in. 9 square root of 6. Okay, so he did 81 times 6. Hey, I know the square root of 81 is 9, so it's 9 square roots of 6. It's perfect. Your group can have a point. Okay, number 10 is actually a little tricky because in my head I saw 800 and I wanted to do 8 times 100, and that is not the right perfect square to choose. That is not. And we'll let you no, not. So close, so close. Okay, Travis, handle it again.
20 and square root.
No, yeah.
Because you're going to do 400 times 2. Hey, I know the square root of 400 is 20. Now, was that my first gut thing? No, but it's the right thing to do. 400 is bigger than 100. It's a bigger perfect square, and it does end up making life work out perfectly. That's great, Travis. Number 11. Yes, please, ma'am. Save us. 7 square root of 2. Okay, so 49, and you can have a point for that. 49 times 2 is 98. Square root of 49 is 7, so 7 square roots of 2. Perfect. You know this is the easiest one, but number 12 is the easiest one, and we're going to let you handle it. We're going to let you handle it. Yep. I don't know why we did the easiest one last week. Yes, 16 times 2, and square root of 16 is 4. That was perfect. Awesome. Your group can have a point for that. Okay, so those are pretty easy if you recall your perfect squares. 13 and 14 are tomorrow's problem. If you're trying to get ahead, that's what I would go ahead and work on. 14 looks tricky. My suggestion is to be brave. And on the third equation down, it looks like it's in standard form. I would rearrange it into slope-intercept. So you want y on one side, everybody else on the other, and graph like normal. I swear you can do it, just be brave. Okay, we're on our notes today. We're not going super out of order. We're third page in. It says 27 at the bottom. Third page in, it says 27 at the bottom. Okay. A few weeks ago in our math workshops, the top 6 problems were all about different parent functions. And we talked about parent functions tend to go through what points? Jessica, your group gets a point. Parent functions tend to go through the origin. Today, we're only going to talk about 3 different kinds of parent functions, and 2 you're super familiar with. So the good news is, the other day we talked about there were like 6. The truth is there were a ton. If you were in pre-cal, you have to learn like at least, I think, 10 of them. There's so many of them you need to know. But for me and you, for now, 3 is going to be enough. So we're going to forget that top line. Whatever. We don't have time for it. First word we're going to fill in is parent. So the parent function is the simplest of the graphs in a family. It's as easy as it can get. And then we can take that parent and transform it to make every other kind of family member. Okay, so we have a constant parent function, which is just a straight line. But if we're being real picky, and I guess I'm going to be today, I guess you could technically say the parent function is not that line at 1, but you should probably say the parent function is y equals 0, because that would go through the origin. If we're trying to make most of our parents, we said most parents are normal and they go through the origin, then I would change the parent function to y equals 0. But I doubt there's any way Andrew's going to mess this up, because regardless, y equals whatever, just go to that line. Okay, we have had a little confusion in the past about y equals being this kind of a line and then x equals being this kind of a line. Okay, we're not going to have that confusion right now because we're never going to do the x equals 1. We're only going to do the y equals 1 because we're only talking about functions. And remember, this one was not a function because it fails that vertical line test. So for once, the x equals part is not going to drive you wild in the parent function section because that's not a function. Yes, dear. Yes, dear.
I'm just going to say that with the y being 1, it's the line next to it, not the x.
Yes. So I think the parent function really is seriously the x-axis of y equals 0. But I mean, do we really have to label a parent for the constants when they're just straight lines? Not really. I mean, you just go to, if it says y equals 7, go to 7. If it says y equals -3, go to -3. I'm just being facetious because I was listing parents for everybody else. It didn't seem fair that that guy didn't have a parent. Okay, so the next one over, I'm going to change the name because I'm rebellious. Even though our learning target and our notes say the word identity function, I'm going to change the name because I don't like it. What should I change it to? What kind of function is this? What would you call it?
A will function. And I'm rising to the top. That's what will function.
Yeah, most people are not going to recognize a will function. What would we call this?
Rise to the top. You see it.
It starts with an L. I'm going to have to tell you, and then I'm not going to give you the point for it.
It starts with what? Wait.
An L.
L, linear.
Yeah, but I gave it to you then. So a linear function. So if you and I just don't think identity describes that function well. I think you and I would recognize it when I say linear function. So we're going to change the name to linear. If Eric wants to put identity, I'm going to recognize that answer on the test, of course. But I'm going to have on my key linear, because to me that's a linear function. Identity is confusing. Okay, so the parent function of a line is y equals x. Just a normal old straight line. But if we were being really kind of super picky today, and you're like, I need you to write it out for me as component mx plus b. So 1x plus 0 is how we could write that out. Because that's as easy as it gets. You put your intercept at 0, your slope is up 1 over 1. You got him in it. Can't get any easier than that. That's why he's the parent. There's nothing easier than him.
Yeah.
Okay. Are there any questions about constant or linear? Then let's go down to the last one, which is absolute value. This is really our new guy to deal with today. We've kind of sort of discussed him in the past, but we're going to spend a lot of time with him today. So an absolute value parent function. I don't know why I didn't write linear parent function, but absolute value parent function is y equals absolute value x. Doesn't get any easier than that. You know, we're about to complicate life by like adding stuff and having like x plus 2, x minus 3, maybe a 2 out front, so 2 absolute value x. We're about to start adding stuff, but as easy as it can get is y equals absolute value x. Let's look at its graph, and we'll come back to how I know this in a minute. But again, parent function goes to the origin. That part's nice. And then it's just like a linear function in that you could count up 1 over 1, up 1 over 1, up 1 over 1. But what makes it different from a linear is that there's nothing negative in the x values. And the reason that is because you can't have, when you plug in a negative number, like if I plug in -2, you know we're not going to get out a -2, we're going to get out a +2. So for instance, -2, 2, whereas on our linear graph, it would have been -2, -2, because we are cool with negatives. We can't have a negative y value with an absolute value function. And even if you didn't really understand this, because for some reason in life that didn't click with me, and when I was younger, I don't know why I didn't know. Just keep in mind it always looks like a V. This left side is always a reflection of that right side. So if we said on the right side we went over 1 up 1, over 1 up 1, we also go over 1 up 1, over 1 up 1 here. And sometimes I don't think about it over 1 up 1. Sometimes I think over 1 up 1, left and right. And sometimes I think over 2 up 2, over 2 up 2, over 3 up 3, over 3 up 3. But if you count it the way you normally count in slope, that's fine too. It's just a different way for me to check myself that I just like counting like that. You don't have to. Okay, like I said, we're going to come back to this graph. No, we're not. We just said all the things I wanted to say about that graph. Good. English, math. Good Lord. Okay, down at the bottom, we've got 3 problems. We need to identify these 3. The first one is, okay, every group can have a point. The first one is absolute value.
Yeah, that's what I was thinking. It's in the negative.
Okay, so no, it's not the parent, but you want to know what parent did it come from. So yes, they picked him up and moved him down to it looks like 6, but the parent was absolute value. Thank you for asking that. Good, you can have a point for that. Okay, so she's right. We're not talking about the parent graphs. We're saying, you know, like whose kid is this, basically? Who does this belong to? And it belongs to the absolute value. Okay. Number 2 is Travis. Number 2 is, everyone else agree with him that it's constant? Yes. It's kind of hard to give y'all a point when he beats y'all to the answer. So say number 3 before he says it. Linear. You didn't beat him. He was first. I don't know how he was first, but he was linear. Okay, and they're kind of easy to identify. So that part seems pretty easy. And so now we get to move to the next page now. So we go to the next page, and it's got a whole bunch of words. So we're going to simplify them because that's a bunch of words. So basically, you know, we agree you've got these parent functions. We can move these parent functions, and when you do something to them, if you move them to the left, for instance, that's called a transformation. So today we're going to talk about 3 different kinds of transformations. One kind is a translation. So if I draw me a little sketch of a graph,
We can't see what you're writing.
if I draw me a little sketch of a graph, a translation is when you take a function and you move it up, down, left, or right. So for instance, I'm going to do the parent function dotted. That way you can keep them straight. For instance, I could take the absolute value parent function and move him down 3. And that would be a translation. So here is an example of a translation.
Would it still be an absolute value function if you did that?
Yes, it's still an absolute value function. All we did was pick up the parent and literally just move him down 3. And we could pick him up and just move him left 10. We can do lots of things with him. Okay, the next thing, that's a good question there. The next thing is a reflection. So a reflection is what it sounds like. A reflection just flips it. So we're literally going to flip. So if we had our parent function and it was a V going through that origin, there's that absolute value parent function again. And if we reflect it over the x-axis, then we literally flip it. We just flip him down. So we can translate it where we move it left, right, up, down. We can reflect it where we just flip him upside down. So he was a happy V, now he's a sad V. And last but not least is there's a dilation. Now a dilation is super cool because you either get fatter or you get skinnier. Okay, so let's see. Here's our parent. depending on what number we use, we either shrink or enlarge. That's how the math people put it, shrink or enlarge. Me, my math vocab, not so good on this one. So I say he either gets fatter or he gets skinnier. For instance, he could get way fatter, like that green guy. Or he could get super skinny, like this red guy. Regardless, the green and the red are both absolute value functions, but the green guy is a much fatter guy, the red guy is a much skinnier guy. And I swear we're going to work examples, and I'm going to say this again, but it wouldn't hurt you to already hear this phrase because it sticks with me. You know, we're worried about what number outside the absolute value is what it's going to do. So it's y equals, and there's some number and then absolute value x. Depending on that number is whether or not we get skinnier or fatter. And so what I remember is this key phrase. Fractions make you fat. Fractions and fat both start with an F. If you have a fraction outside, it makes you fat. Now, in my gut, does that feel right? No, because you think fractions are tiny things. Fractions make you tinier, which is true. It makes the value smaller, which makes the function stretch so far. So fractions, and so back to layman's terms, fractions make you fat. If you remember fractions make you fat, then life gets better for you. Okay, so of course we're not trying to super confuse you, but we wanted to have a table from your book to help you go over this. But of course the table uses H's and K's, like you know what the crap an H and a K is or an A is. Like no one can read this unless you're a math teacher, which is understandable. So it's really saying what we just discussed. The only thing I want to hit on a little further is with translations, what makes you translate how. So for instance, if it's x plus 2 inside or x minus 2 inside, that moves different ways than x plus 2 on the outside of the bars and x minus 2 on the outside of the bars. So obviously some way is going to be up, some way is going to be down, some way is going to be left, some way is going to be right, and we have to pay attention to, is it a plus, is it a minus? Is it inside the bars, is it not inside the bars?
The 4 things you wrote there supposed to be lined up with the translation.
No, not well, no, but yes. I didn't do it in exact order now. I wasn't even paying attention to exact order. But I did. Yes, I did. I did the exact order. I didn't even need to. Okay. Now let's go to the third one down, the plus 2 on the outside. Take a guess. How do you think that would make you move? Up, down, left, right?
Up.
It does. It would make you move up 2. So it would take your parent function and literally just pick it up and move it up 2. In the same way, the minus 2 on the outside is going to make it move down 2. And you're like, oh, this is super easy. On the outside, plus 2 up 2. So it must be on the inside, plus 2 makes you move. That's what you would think. But it actually ends up being the opposite direction on the inside. So you would think plus 2 would make you move right 2 when it's inside the bars. But plus 2 actually makes you move left 2. And minus 2 actually makes you move right 2. So inside the bars is the opposite of what you think. It's terribly annoying, but it's the opposite of what you think. It's going to be fun. Because we have this handy dandy thing that I'm not going to take away from you, so you could always ask it at any time, like, hey, am I being crazy right now? I mean, it won't literally answer you, but if you press the right buttons, you can check your crazy level. Okay, we're only doing graphs today, so we're going to skip one at the bottom, flip to the next page. We can't do 2 through 7. We got to go down to number 1. We're only dealing with the graphs today. We'll come back to the others tomorrow. They are tomorrow's issues. So I'm on page 29 at the bottom. I'm starting on number 1. Okay, there is a plus 3 inside the bar. How do we assume that's going to make the parent move? It's going to go left 3. So it used to go through the origin and be a V. Now we're going to pick him up and move him 1, 2, 3 to the left, and then it's still over 1 up 1. Over 1 up 1. And you've got your V. Yay! So all we did was pick up the parent function and move him left 3. That's all we did. Okay. If you said, no big deal, If you got it, then you're only going to need the calculator to check yourself. If you said, and you really don't know how I came up with this, we're going to discuss right now how to get this from your calculator. Okay, so if on your calculator, let me zoom out so you can see all the things I pressed. So I wrote the equation again over here so I can reference it. Okay, if on your calculator you have it on and you want to graph, you press y equals. It's the top left gray button, y equals. Notice there's nobody else in my list right now, so if there's someone else in your list, you probably want to erase them. Okay, I need to type in those bars somehow. I need absolute value x plus 3. I don't see that button anywhere on this main screen. So you have two options. Your first option is to know your alphabet. Absolute value is ABS. So you could press the alpha button and then the letters A, B, S and put it in parentheses. You could press alpha and then the letters A, B, S. But if you don't understand that and you're like, what did you just say? Don't do that. Instead, press math. Scroll over to NUM for numbers. And we want the first one on the list. That's ABS. So let me do that again. You press math. You scroll over one to numbers. It's NUM. And we want that first one down. It's ABS. So you press enter. But hopefully you were still on your graph. I wasn't. So, okay. I'm on my graph. Math. Numbers. ABS. And look, it puts the bars for us there. So when we type X, it is the button that says a bunch of other stuff. It has X, T, theta, and N. That's the button that's going to be X. So you press it, you get X. It's right here. And then you press the plus button and then 3 as normal. Notice that since the plus 3 was inside the bars, on my calculator screen, I made sure the plus 3 was inside the bars. If Andrew gets the graphs wrong, he probably told the calculator wrong. It's not the calculator's fault. So if the plus 3 is supposed to be inside the bars, put the plus 3 inside the bars. Okay, so if you're here and you press enter and then you're mad because it didn't actually graph it for you, well, duh. You have to actually press the button that says graph. So you need to press the graph button. Is there anyone lost here? Okay, so you were at y equals. Did you figure out how to get to ABS? Did you do math, NUM, ABS? So you did math, NUM, ABS, and then you did X plus 3?
I don't see any.
Scroll over one. Yes, dear. I'm going to show you what to do for that. Did you get a graph? It's just not zoomed like mine? Is it a B? Oh, did you type in the letters ABS? As long as you put it in parentheses. So if you did the letters like we talked about, you press third and then did you spell out ABS with alpha? Okay, if yours just has the letters ABS, as long as you have it in parentheses, it's the same thing. So you had ABS, let me put, let me show you on the board. If you do ABS and then put in parentheses X plus 3, it's the same thing as the bars X plus 3. They mean the same thing. They mean the same thing. So it depends on if you got a yellow one or a black one. I get that now. If you have an 83, you're going to have to put it in the parentheses. If you have one of my 84s, it already shows up with the bars for you. So now you know why you might want to buy an 84 in life. It's one of those tiny little features that makes it cool. Okay, so you press graph. Say everyone has the equation in that wanted it. Okay, you press graph and you get your graph. Let's say people have been messing with your calculator, or you just don't like the zoom of that graph. You don't like how it's zoomed in. You can change that. There's a button for that. It says zoom. So if you press zoom, you could zoom in, you could zoom out. I don't press either of those. I press zoom standard. It's the 6th one on the list. Zoom standard considers your graph and then zooms to your graph. That's why zoom standard is probably the best option. So we want zoom standard. Okay, and now I'm pretty happy because that graph does kind of look like my graph. So I think I'm right, but I'd really like to make sure. So I'd really like to know that that bottom point is the same as my bottom point. So you have some options to check that. You could, someone last period knew something fancy, which is good. You could press second table. and then compare points. For instance, 0, 3, 0, 3, yep, that is a point. So you could check the points from the table. Are the points on your graph the same as the points on the table?
What you said?
You could.
Like
It's
what?
second and then table. It's by the graph button. It's second graph. That's where the table button is. But if you don't want to do that, press graph again if you don't want to do that. You do second and then table. It's written in blue on the graph button. So that's why you have to press second so you can get to it. Second, table. But if you don't want to do that, because that list of values is confusing for you, even though it's genius, because it's all the points that should be on your graph, and you could scroll the other way to get the negative ones. I mean, it's pretty genius. But let's say you don't want to do that. There are other ways. All Sarah wants to do, really, she thinks she's got the V part right. She's just wanting to check that bottom number. Is that bottom point really the same bottom point I did? So she could, your calculator's cool, and you can just scroll over with it. And if you do that, you're like, negative 2.97. Well, I mean, that's almost negative 3. So, yes, I was right at negative 3. You could use that kind of logical reasoning. Or, even cooler, there's a button in between zoom and graph that says trace. And if you press trace, the cursor is literally following your graph around. So, it follows your graph. So, you could go to that point you're curious about. I'm curious about this bottom point here. And you're like, oh, Miss Compton, it's still doing that weirdo 2.97. I'm just not, should I move my graph to 2.97? So, when you ask yourself that question, you and I both thought it should be at negative 3, right? So we can ask it. If you press trace, you can ask it about a specific value. You could say, hey, what's the deal at negative 3? You press enter and it tells you 0. So again, if you press trace and you're worried about a specific point, the way you and I were worried about negative 3, 0, is that really it? You can ask it. At negative 3, what's the y value? It's really 0.
We should have like a secret, but that's not.
It's really 0. So again, there are like 5 different ways to check yourself to make sure your graph was correct. When darn, Davey Redu, his graph was correct to begin with because he understood plus 3 meant just pick up, move left, right. Okay, so everyone good?
Yeah.
Let's move to the next one on the back. So I see absolute value x minus 4. What do we assume that minus 4 does? And since it's on the outside, we assume it goes down 4. So if you're good with that, then literally I'm going to zoom in. I'm going to count down 4. It was at 0, 0. 1, 2, 3, 4. And then I do my normal. Everyone up 1. Everyone up 1. And I can make my normal V. Woohoo. Yay. I did not extend that side as far as I did the other side. That's annoying. Oh well. Yay. If you wanted to check yourself and graph it, you could. You can. It's not, I mean, it's easy to change. Just delete the others and say, oh, minus 4 on the outside. Graph. It's not a big deal. And oh, look, it is exactly what we wanted. But again, Abby Grace has caught on by now. And she might let me do a quick check to make sure she's that crazy. But she doesn't have to study the graph until it really gets to a hard problem. The graphing calculator helps you make sure you're not crazy, but if you know what you're doing, you don't need it until we get to a hard problem like on the next page. You don't even really need it then. Okay. Are there any questions on 2? Then on 3, with that negative on the outside, what do you think is going to happen? What do you think is going to happen? We move left, right, up, down. We're going to flip upside down. Literally that negative side. Instead of being a happy V, we're going to be a sad V. We're going to still go through the origin, and we're just going to be sad. Over 1, down 1. Now, that seems pretty obvious. And I'm betting you could kind of, I mean, there were at least 2 in the room who knew that on their own. But again, if Abby Grace wants to check herself, she could graph it. And I'm going to recommend Abby Grace graph this one so we can discuss a specific button she should not press. Okay, so go back to y equals on your calculator. When you want to graph something, like we're wanting to graph negative absolute value x, we're wanting to graph negative absolute value x, That's not minus absolute value x. So don't press the minus button. Your graph's going to say invalid, it's not going to go, and you're going to be mad. The negative absolute value x, you better actually press the negative button. Negative, and then normal thing for the absolute value x. But lo and behold, the amount of calculators that are going to be brought to me next Tuesday, my calculator did it wrong. No, it didn't, you sweet, sweet person. You didn't press the right negative symbol. So when you press y equals, when you press negative absolute value x, make sure you press the negative button and not the minus button. Okay, I know I've got at least one person with a question. Ask me your question. Ask me your question. What's wrong? You're mad at something. Say it again. What are you mad at? You look frustrated, Travis. What are you frustrated with? Okay. Okay, so if you're hating on the calculator, which bless it, so am I, and we're trying to speed up our life because my goodness is something, we only got 10 minutes left. How are we going to finish all these? And I swear we're about to finish the rest like lickety-split. Let's do these like nobody's business. The plus 3 on the outside is going to move me how?
It's gonna move up 3. No,
Up 3.
Yeah, up 3.
It's on the outside, so it's going to be up 3. The minus 2 on the inside is going to move me how?
Right.
Right 2. So literally I'm going to pick up my parent function. It was at the origin. And I pick him up and move him right 2, 1, 2, up 3, 1, 2, 3. Again, you told me right 2, up 3. I move my bottom point there. It's called a vertex, but today just the bottom point. I move my bottom point there, and then it's just like normal. Over 1, up 1. Now you can quickly check it with your calculator if you want, and you can rely on your calculator if you want, but if you understand what's going on, lickety-split, we're done. Are there any questions on number 4? Yeah, Whistlers super annoy me. Like on a scale of 1 to 10, they're at like a negative 10. I do not.
Why not? You not whistle?
No, I can't whistle. That must be it. No, I really just don't like it. We've already discussed I have like ADHD. Random noises, really? That's going to help me? Sure. Okay, flip to the back. Another easy one. And you think it's not easy, but it is easy. Number 5. What's the plus 1 going to make me move? Is it left 1? The plus 1 does make me do the left 1. Yes, it does. Okay, I'm going crazy. What's the minus 2 make me do?
Down 2.
What's that minus sign on the outside make me do?
Negative.
So I need to go left 1. So it was at the origin. I take it left 1. I go down 2.
Yep.
Again, it was at the origin. I went left 1, down 2. And then you told me it flipped. So I'm just, instead of a happy B, I'm going to make a sad B. I think every group's going to eventually get to a 5, except for the group that had the members asleep, because that was unnecessary. Getting on my nerves. Okay. Are there questions about that one? Now, you know we've not done a single dilation one, so you can already assume dilation's happening on 6 and 7. We discussed earlier that fractions make you fat. So fractions are going to make us fat. So on number 7, we're expecting to get a fat graph. On number 6, since it's a 3, we're probably going to get a skinny. So instead of being our normal V over 1 up 1, life's going to change. So you can put it in your calculator. No one said you couldn't. So you can do 3 absolute value x graph. Oh, lo and behold, it does look pretty skinny. In fact, it would be smart on a dilation problem to probably graph the parent function as well. So maybe in y2, you should put math absolute value x just all by himself. And you're like, why would I graph 2 things at once? Well, maybe it would help you see better, like, how skinny it got. That's one suggestion. But then, to be honest, I still don't have to graph with my calculator on 6 or 7. I don't. So let's talk about why I don't actually need my calculator for 6 or 7. Okay, so on number 6, we put ours at the origin. And then you and I both know it's supposed to get skinny, right? We used to go over 1 up 1. That number tells you how much to multiply by. So instead of going over 1 up 1, we're going to go over 1 up 3. So if that number was a 4, we go over 1 up 4. If that number was a 6, we go over 1 up 6. Whatever number is on the front is telling you what to multiply by. So instead of over 1 up 1, I'm going over 1 up 3. And I could keep going from that. Over 1 up 3. Over 1 up 3. I could do the same thing on this side. And lo and behold, I've got the same skinny v that my calculator had. And I didn't even use my calculator. I just used my brain. It is okay if you use your calculator. I'm never going to know as long as you get it on your paper correctly. I'm not going to know what you did. Any questions on 6? Okay, well on 7, we talked about the fraction's going to make you fat. I know I started the origin, but instead of going over 1 up 1, because it's a half, I literally go over 1 up a half. So if you just keep going over 1 up a half, you'll get the graph that your calculator would have given you anyway. Over 1 up a half, over 1 up a half, over 1 up a half. And you end up getting, hopefully you can connect the dots better than I can today, you end up getting a fat V. Now, it's not super fat. It could be fatter. The larger the denominator is, the fatter it's going to get. In fact, we could get so fat we almost look like a straight line, because there's that fat with a V. You can imagine it. Like, if it opened up wide enough, it would almost look like a straight line. But we are fatter than the parent function. And if you wanted to, for fun, you could even put that on the same graph, just because, I don't know, you like seeing lots of things at once. And look, there's the super fat guy. So I've got the normal guy in between, the skinny guy at the top, and then the fat guy at the bottom. And I could graph all the things on the screen at once, and if I had a fancy enough calculator like I think Abby Grace does, it would graph them all in color and you could keep up with who's who. Okay, if you were smart, you would start 32 through 34, because that will be your homework this weekend. But if you want to be done, you can. If you didn't finish your checkpoint yesterday, I haven't typed in the grade for that yet, you wouldn't get it done.
Is the mark
Yes,
due Monday?
We're going to say